Hello, my name is Emmalee Phillips, and this is my presentation for Project and Portfolio 7. Today I will be talking about system hardening. So let's get started. Let's start with our topics for discussion. So what exactly will we be going over today? So today we'll be talking about what the project scope is for this project, what the network diagram will look like for this project, what the statistics are, what the lessons learned are, and then we'll do a brief demo showing how the Ansible playbook works. So what will be accomplished in this project? This project aims to implement 20 to 30 distigs onto two newly created DigitalOcean droplets. So this project will utilize Ansible to automate the creation of those droplets and the implementation of the stigs onto those droplets. All of these steps will be accumulated into a single Ansible playbook. So by using a single Ansible script, it will allow for quicker, more effective installation, and then it will also save a company money and time in the long run. So the anticipated completion of this project is set for October 21st or 24th, 2021. The project will be segmented into 4 separate milestones. Milestone 1 will consist of research on Ansible, distigs, and stig implementation using Ansible. And then milestones 2 and 3 will consist of configuring the CentOS 8 control node with Ansible and the creation, editing, and testing of the Ansible playbook. And then milestone 4 will consist of the finalization, testing, and validation of the Ansible playbook. So here's our network diagram. As you can see at the top, represented with the laptop icon is the Ansible control node, which is a CentOS 8 VM configured with Ansible. This will communicate with DigitalOcean, which is represented by the cloud icon. And then with DigitalOcean, the playbook will create 2 servers named with the Phillips E-2110-STIG format. And then on these servers, the STIGs will be implemented. So distigs, what are these exactly? Distigs are security technical implementation guides that are configuration standards developed by the Defense Information Systems Agency. So DISA refers to the organization that provides the technical guides, and these technical guides are the STIGs. There are 3 compliance levels. The compliance level kind of lets you know the severity of the risk if they're not implemented with certain hardening techniques. These levels are Category 1, Category 2, and Category 3. 1 represents the most severe risk if not implemented. So by utilizing distigs, companies are really ensuring that they're staying compliant and operating at an optimal security level so that they can minimize any damage that might be caused if these stigs are not implemented. Lessons learned. So what did I learn throughout this project? So throughout this project, I was really challenged on my ability to be able to troubleshoot errors as they occurred and knowing when and how these errors were occurring. Having a base knowledge of what Ansible was and how to create and run a playbook really worked in my favor for this project. So instead of spending a great deal of time learning how to use Ansible, I was really able to have Ansible work for me. So for example, when I was running my playbook and I would get those big red letters that kind of indicated, hey, there's an error, and they would halt my script, and I really didn't know why that error was occurring. I would run the playbook command with -vvv, and it would give me a log of what was happening with the script, and I could further troubleshoot the error with more knowledge instead of having to pretty much take a shot in the dark on what to research and how to fix this problem. Also, for the first time, I used a role in one of my own scripts. So while doing this really had its challenges for me, it really made for a great learning experience and helped to build on my previous knowledge of Ansible. This project also really had me dive deep into what distigs are and helped to create a strong base knowledge on the importance of hardening your system. So let's start with this demo. Just exit out of here. I'm going to open my control node. Just log in really quickly. Oh. What is going on? Here we go. I already have my terminal open, so I have to go to my Ansible directory. And then to run my playbook, I will use the Ansible playbook command. My playbook is called playbook. And then I will run that with that script. So it's communicating with my script. It's gathering the facts, creating my SSH key, ensuring that SSH key is there. And now it's creating an SSH key for DigitalOcean using the information from the SSH key with my control node. It's now creating the droplets. This sometimes takes a little bit of time depending. Okay, there it goes. So as you can see, there's changed. So that means that that is a new server being created. This one's called Phillips E-2110-STIG 3, and I believe the next one should be 4. That didn't take too long. Okay, so then up here, it's going to add the droplets. So the droplets were created. So now the droplets were added to the host file or the inventory file. And this is all the information on those. And then there's a slight 30-second pause to allow for the droplets to finish creating and give them a chance to finalize everything. And now, as you can see, that pause is completed. So now we're trying to SSH into these droplets. So I just have to say yes to both of these. And now that it says okay and it's green, it's able to communicate. So it's going to be installing the EPEL release, Python, and pip so that it's all up to date and the playbook can run on the role can run on the droplets. While we're waiting for that, we can go into DigitalOcean. This is the default page. As you can see, they pop up here, STIG 3, STIG 4. When you click on them, it gives you the information on the images that I use, the size, things like that. Same here. So it's just finishing these installations. Once it's done with this, it'll be tasked to run the role. There we go. So this is some of these are a bunch of preliminary checks so that the role can run smoothly. A lot of them will be skipped because they're not needed. And then some of them, as you can see, the ones that are being implemented or changed are going to be green. The ones that are changed are going to be yellow. You can tell these are still preliminary because they say prelim, and then once they get to the other controls, they'll say right in this area, hard, medium, low, and it'll let you know which ones are being changed. Sometimes this takes a little bit of time, especially because these were newly created VMs, so some of this stuff has to be changed before it can run the other controls. If I had already ran this script before, it wouldn't take nearly as long. It would run through it pretty fast because not a lot would need to be changed. So here we go. Now it's starting to get into the controls that are being changed. As you can see, it's skipping over a lot of them because we're only implementing 20 to 30 of them. There is over, I believe, 300 of them. So you'll see a lot of blue because a lot of it's being skipped. If we go on to here, if it will load, you can see this is when it was created, and now there's a bunch of activity. CPU is really high. So let's go back to this. It is a bit of a waiting game. Okay, now we're kind of getting to the more interesting things. A bunch of things are going to start changing. You'll see a lot of things being checked and okayed. It seems that we're nearing the end of the Ansible playbook. There's a small wait. And then at the end of the playbook, it'll kind of give us a small status report on how. Oh, no, okay, there we go. So now there's the play recap, or as I had called it before, like a small status report on how everything went. As you can see, there were 530 different things that were skipped, and then there were also 36 different changes being made. So with this playbook, we were able to successfully create those two droplets. As you can see over here, these are the two new droplets, and then we were able to run an update on those, and then we had the stig implemented. 20 to 30 stigs implemented onto those droplets. Thank you so much.